Chapter 2. Living Labyrinths. Imagine that you could pass through two doors at once. It's inconceivable, yet fungi do it all the time. When faced with a forked path, fungal hyphae don't have to choose one or the other. They can branch and take both routes. One can confront hyphae with microscopic labyrinths and watch how they nose their way around. If obstructed, they branch. After diverting themselves through an obstacle, the hyphal tips recover their original direction of their growth. They soon find the shortest path to the exit, just as my friends' puzzle-solving slime molds were able to find the quickest way out of the IKEA maze. If one follows the growing tips as they explore, it does something peculiar to one's mind. One tip becomes 2, which becomes 4, which becomes 8, yet all remain connected to one mycelial network. Is this organism singular or plural, I find myself wondering, before I'm forced to admit that it is somehow improbably both. Watching a hypha explore a single cynical maze is bewildering, but scale up. Imagine millions of hyphal tips, each navigating a different maze at the same time with a tablespoon of soil. Scale up again. Imagine billions of hyphal tips exploring a patch of forest the size of a football field. Mycelium is ecological connective tissue, the living seam by which much of the world is stitched into relation. In school classrooms, children are shown anatomical charts, each depicting different aspects of the human body. One chart reveals the body as a skeleton, another the body as a network of blood vessels, another the nerves, another the muscles. If we made equivalent sets of diagrams to portray ecosystems, one of the layers would show the fungal mycelium that runs through them. We would see sprawling interlaced webs strung through the soil, through sulfurous sediments hundreds of meters below the surface of the ocean, along coral reefs, through plant and animal bodies, both dead and alive, in rubbish dumps, carpets, floorboards, old books and libraries, specks of house dust, and in canvases of old master paintings hanging in museums. According to some estimates, if one teased apart the mycelium found in a gram of soil, about a teaspoon, and laid it end to end, it could stretch anywhere from 100 meters to 10 kilometers. In practice, it is impossible to measure the extent to which mycelium perfuses the Earth's structures, systems, and inhabitants. Its weave is too tight. Mycelium is a way of life that challenges our animal imaginations. Lynn Boddy, a professor of microbial ecology at Cardiff University, has spent decades studying the foraging behavior of mycelium. Her elegant studies illustrate the problems that mycelial networks are able to solve. In one experiment, Boddy allowed a wood-rotting fungus to grow within a block of wood. She then placed the block on a dish. Mycelium spread radically outward from the block in all directions, forming a fuzzy white circle. Eventually, the growing network encountered a new block of wood. Only a small part of the fungus touched the wood, but the behavior of the entire network changed. The mycelium stopped exploring in all directions. It withdrew the exploratory parts of its network and thickened the connection with a newly discovered block. After a few days, the network was unrecognizable and had completely remodeled itself. She then repeated the experiment, but with a twist. She let the fungus grow out from the original block and discover the new block of wood. However, this time, before the network had time to remodel itself, she removed the original block of wood from the dish, stripped away all of the hyphae growing out of it, and placed it onto a fresh dish. The fungus grew out from the original block in the direction of the newly discovered block. The mycelium appeared to possess a directional memory, although the basis of this memory remains unclear. Boddy had a no-nonsense manner and talks with a quiet amazement about what these fungi are able to do. Their behavior is a bit like that of slime molds, and she has tested them in similar ways. However, rather than modeling the Tokyo Underground network, Boddy encourages mycelium to work out the most efficient routes between the cities of Great Britain. She arranged soil into the shape of the British landmass and marked cities using blocks of wood colonized with a fungus. The size of the wood blocks was proportional to the population of the cities they represented. The fungi grew out from the cities and made the motorway network, Bobby recounted. You could see the M5, M4, M1, M6. I thought it was quite fun. One way to think about mycelial networks is as swarms of hyphal tips. Insects form swarms. A murmuration of starlings is a swarm, as is a school of sardines. Swarms are patterns of collective behavior. Without a leader or command center, a swarm of ants can work out the shortest route to a source of food. A swarm of termites can build giant mounds with sophisticated architectural features. However, mycelium quickly outgrows the swarm analogy because all the hyphal tips in the network are connected to one another. A termite mound is made up of units of termites. A hyphal tip would be the closest we could come to defining the unit of a mycelial swarm, although one can't dismantle a mycelial network hypha by hypha once it has grown, as we could pick apart a swarm of termites. Mycelium is conceptually slippery. From the point of view of the network, mycelium is a single interconnected entity. From the point of view of a hyphal tip, mycelium is a multitude. I think there's lots we can learn as humans from mycelium, Body reflected. You can't just go and close a road to see how traffic flow changes, but you can sever a connection in a mycelial network. Researchers have begun to use network-based organisms like slime molds and fungi to solve human problems. The researchers who modeled the Tokyo train network using slime molds are working to incorporate slime mold behavior into the design of urban transportation networks. Researchers at the Unconventional Computing Laboratory at the University of the West of England have used slime molds to calculate efficient fire evacuation routes from buildings. Some are applying the strategies that fungi and slime molds use to navigate labyrinths, to solve mathematical problems, or to program robots. Solving mazes and complex routing systems are non-trivial exercises. This is why mazes have long been used to assess the problem-solving abilities of many organisms, from octopuses to bees to humans. Nonetheless, mycelial fungi are maze dwellers, and solving spatially and geometrical problems is what they have evolved to do. How best to distribute their bodies is a question fungi face on a moment-to-moment basis. By growing a dense network, mycelium can increase its capacity for transport, but dense networks aren't good for exploring across large distances. Sparse networks are better for foraging across large areas, but have fewer interconnections and so are more vulnerable to damage. How do fungi juggle this kind of trade-off while exploring a crowded rotscape in search of food? Body experiment with 2 blocks of wood illustrates a typical sequence of events. The mycelium starts in an exploratory mode, proliferating in all directions, setting out to find water in a desert. We'd have to pick one direction to explore. Fungi can choose all possible routes at once. If the fungus discovers something to eat, it reinforces the link that connected it to the food and prunes back the links that don't lead anywhere. One can think of it in terms of natural selection. Mycelium overproduces links. Some turn out to be more competitive than others. These links are thickened. Less competitive links are withdrawn, leaving a few mainland highways. By growing in one direction while pulling back from another, mycelial networks can even migrate through a landscape. The Latin root of the word extravagant means to wander outside or beyond. It is a good word for mycelium, which ceaselessly wanders outside and beyond its limits, none of which are present as they are in most animal bodies. Mycelium is a body without a body plan.